Okay, good morning and welcome to the next session. It's my pleasure to be here today to introduce Johan Rockström from the Stockholm Resilience Center. I'm William Clune from the Sustainable Earth Office here at NTU. By way of brief introduction to this talk, this type of work makes me think of a particular type of socio-ecological system, and that's Singapore, and in particular, also involving the regional system in which Singapore is reliant for resources and food. As has been mentioned a few times already, a population white paper has come out here recently with ongoing discussion and debate and some controversy. When I look at some of the main concerns among Singaporean voters, some of the big issues, they often look like this. Stable and reliable economic opportunities going forward, the transportation system in terms of capacity, crowded roads, more coverage, price of vehicles as well, housing, availability, scarcity, increased prices, immigration and overcrowding, the price of food, energy, water. Applying our conference theme, taking even a crude look at that whole, and sustainable development, sustainable urban development, is at the very heart in a totally connected way in and among those big issues. And in Singapore, they are, as in other places, starting to bind in terms of hard constraints, but also politically. Thinking about resilience, the risk of unsustainable development, including non-resilient or non-robust systems planning, including both from a city perspective and a regional perspective, the risk is that it doesn't have to lead to smooth or manageable transitions, not linear, not predictable, not gradual, a worst case outcome being a crash or crashes ecologically, economically, politically. What our next speaker has to say is more important than ever to places like Singapore and Southeast Asia. Please welcome now Johan Rockström.
Thank you, William, and good morning, everyone. What I will do is, in a way, quite simple. I'm trying to put some additional scientific flesh to why Simon's talk is so absolutely critical at this juncture of time. The understanding of how ecosystems connect to the biosphere and how nonlinearities and complexities interplay with human development has become absolutely central in a moment in time for human development where we're moving from a connected to a hyper-connected and from a hyper-connected to an interdependent socially, politically, economically, and ecologically globalized world. And I think there is a good argument to say that this may be the most important scientific message to humanity in recent years, namely the empirical evidence over the past 10, 15 years coming together in major synthesis from Earth system sciences, suggesting that we've entered a new geological epoch where humanity constitutes a quasi-geological force in the driving seat in par with the natural geological changes, simply fiddling and influencing the Earth system at the global scale. This notion of the Anthropocene was suggested for the first time, as I'm sure you're aware, of the Nobel Prize laureate Paul Crutzen in 2002. It was synthesized in 2004. It's been coming out more prominently from 2007, 2010. And of course, you're aware of where the decision is taken in the world of what is on our high school walls on geological eras is, of course, the Royal Society in the United Kingdom. And the Royal Society has applied a whole commission to decide whether we should change our current epoch from the Holocene to the Anthropocene. So this is major, big issues when it comes to changing the face of sustainable development. The necessity of moving from what you could argue a bit provocatively to be today an obsolete definition of sustainable development, the kind of Brundtland view of the pillars of sustainability, of social, economic, and environmental sustainability, which is largely, as you know, successful in some sectors, been translated to minimizing environmental impact on a growth model, which essentially is the linear, incremental, predictable, and optimization-oriented growth paradigm we have, into recognizing a very dramatic but simple conclusion that global sustainability increasingly seems to be, on evidence, a prerequisite also for local human well-being. So that growth for Singapore or growth for a country like Sweden is interconnected and dependent on sustainability across the entire biosphere. Now, when I lecture to my students, I increasingly say that, the future that you need to navigate is the 369 world. It's a world that largely in the mainstream of climate science shows that we're more or less committed to a 3-degree warming. We've entered the 6th mass extinction of species on planet Earth, and we're committed to 9 billion people. And this 369 world is essentially what we have in front of us in a biosphere shaped by humanity. That is the Anthropocene. You may have seen the very important synthesis made in Science just over 1.5 years back, showing the evidence behind the drama of the Anthropocene, the number of hockey stick patterns. And I can assure you that you can choose essentially any parameter you wish that matters for the economy. They have the same pattern of exponential rise. We normally just focus on the bottom one, which is population and carbon dioxide, but they look the same. And just as examples in the upper left-hand corner, the fact that we have emptied 70% or so of the fish stocks in the ocean, and ocean acidification amplified by greenhouse gas emissions, which I'll come back to. So there's a very large empirical basis. In fact, it's so large that we can say that we're the first generation to know that we're starting to hit the ceiling of the hardwired biophysical processes at the Earth system scale. This is an enormous privilege because it means that we're the first generation also to have no excuse for inaction, which is quite a good position to be in when it comes to the 40, 50 years of uncertainty that we've been facing for so long. Now, the reason why we are in this predicament, so well understood in this room, of course, is what I call a quadruple squeeze. And we tend to sometimes not see that crude whole, namely that, of course, human pressures is a predominant factor here, but it's not the numbers of people that is the number one issue. It's the 2080 dilemma, the fact that the environmental negative pressures on the planet so far have largely been caused by the rich minority of the planet, the 1-point-something billion that stepped onto the Industrial Revolution 150 years back and have caused the bulk of the dilemmas so far. The 80% that have caused very little impacts are today on a very positive momentum. In fact, we're facing a future where we're moving from 1.5 to 4, 5, 6 billion of middle-class citizens with a purchasing power and an aspiration for lifestyles largely equivalent to the unsustainable lifestyle that's caused the problem so far. This is the big gear, the social gear, which we're just putting in right now. We have the climate change pressure, of course, which is a drama in itself. We know increasingly that we need to stabilize greenhouse gas concentrations at 350 ppm for CO2. We are at 390 ppm, and we are rushing decisively towards 560 ppm and beyond. Just the stock market value, as you know, of the energy utility companies in the world, which have documented reserves of more than 5 times the amount of carbon that would take us to a safe level, just shows that the energy utilities don't bother about climate policy. They're simply moving along, assuming that we're not going to bend the curves on emissions. You would have wished that this anthropogenic disturbance of the entire climate system would have occurred on a resilient planet, a planet able to buffer the disturbance of the energy system. But we know from the Millennium Ecosystem Assessment that never before, as in the past 50 years, have we undermined ecosystem services as fast as in this period. So we are in this dilemma that we are eroding the very basis for resilience at a moment in time where we would have needed a strong Earth system more than ever. And as if this was not enough, the playing field for humanity seems to be diminishing in a recognition that nature is not this Walmart store where you just walk in and pick natural resources from a shelf, and when a resource goes down, someone seamlessly just fills up the resource. In fact, long periods of very slow and incremental change can abruptly shift through triggers and feedback mechanisms into state shifts, as was pointed out so eloquently by Simon. So this is the new game for human development in the Anthropocene. It's an entirely new agenda. It's so new, in fact, that even UN Secretary General Ban Ki-moon pointed out, I think for the first time in his Global Sustainability Panel, the Brundtland Commission equivalent report to the Rio Plus 20, that the current development paradigm does not work anymore. And we need to recognize the risk of catastrophic tipping points. This is stated in a panel of heads of state informed by science. Of course, it had very little influence in Rio, but it, in fact, is a very, I think, pertinent shift in what we are dealing with. Now, throughout this conference, there's been, and I'll be coming back to it myself, so many examples of nonlinear dynamics and state shifts between stable equilibria at the ecosystem scale. but it seems to be climbing in scale. And you may have seen this, I think, incredibly important data from NASA, the satellite observations over Greenland, where 2012 may be remembered in 10 years' time as the very point where feedback directions shifted from largely an era of dampening, negative feedbacks that have, to put it a bit simple, Earth helping humanity to dampen our impacts of environmental change, to reinforcing and accelerating change. So what this is just albedo measurements over Greenland. You see the typical, in the colored lines, what we wish to have, namely roughly 90% of incoming heat from the sun reflected back to space. This tremendously important cooling system of the Earth, a key of the Holocene equilibrium. And then you see in the black line here how in 2012, in July, the albedo goes through the floor, and less than 50% is returned back to space. Now, this sudden shift in feedback is because during a couple of weeks' time, as shown by Jason Boxer and colleagues at the Bird Institute, the entire Greenland continent is melting. And it shifts color from a white to a darker surface. And that absorption of energy is calculated to more than 300 exajoules of absorbed energy, which is more than the annual consumption of energy in the United States. So Denmark climbs past China and the US suddenly to become the largest climate forcer on planet Earth, not because they're emitting greenhouse gases, then Danes tend to bicycle to work, but because of the Earth system putting in its high gear from negative to positive feedback. This is the Earth system responding in a way that way outpasses the kind of triggers that we are, so to say, kicking off in the Anthropocene. Science has been starting to synthesize this message to humanity, I think, in a very effective way. You may have seen, in my mind, the very important State of the Planet Declaration, which comes out as a synthesis of the largest ever gathering of global environmental change scientists, the Planet Under Pressure Conference, in the run-up to Rio, stating clearly that humanity may be reaching a saturation point. Now, this is a very, again, an incredibly difficult statement to make, but built on empirical evidence that we're starting to see so much evidence from the oceans, from the land, from the atmosphere, from the stratosphere, that we're starting to see the risk of these kind of nonlinear dynamics. It's not only about climate, and that we need to start understanding resilience. We need to start understand the need to look at risks of nonlinear dynamics and state shifts, feedbacks, and how to maintain persistency or robustness in the system. But interestingly, the conclusion is also that the window seems to still be open for a transition towards a less risky or even safe future. So it's not as if we're kind of only in a doom and gloom situation, as Brian Arthur and others showed. Through innovation systems and wise economic policy, we can actually trigger a transition, particularly towards a safe energy future, which has perfect substitution to the fossil fuel dependency we have today. Now, so this is changing the face also in even how the world outside science is starting to understand the complexities facing humanity. This is, as we all know, the way business normally portrays turbulence and complexity, the vortex of the Lehman Brothers being sucked into the financial crisis in 2008. But even the economists welcomed humanity to the Anthropocene in 2011. So this is an interesting shift in starting to recognize this interdependent globalized world. And we're starting to see evidence how these two interact. You may have seen recently Thomas Friedman writing in New York Times, referring to the growing empirical science being published, that the Arab Spring, of course, being driven largely by a young, well-educated, frustrated under oppression and socially connected youth. But increasing evidence shows also that exactly at that moment, you had a 160% rise in phosphorus prices. You had an almost 150% rise in wheat prices because Putin shut the borders in Russia due to forest fires, clearly linked to anthropogenic climate change. And Australia, after 12 years drought, also reduced its exports of cereals, which may be one of the first examples at a regional scale, social ecological dynamics playing out in a big social instability in the world of the Anthropocene. So this is the kind of turbulence we're starting just to see at the very, let's say, putative level, but it's still being growing with increasing evidence. You may have seen this Economist issue, and they have a beautiful, in my mind, typical British understatement of how science feels about this situation, which goes as follows, that when reality is changing faster than theories suggest it should, a certain amount of nervousness is a reasonable response. And I think that is exactly where we are today, that in fact, the world is changing faster than theory stipulates it should, and precaution must play in a situation of this kind of uncertainty. Now, of course, the pressures of the exponential human pressures on the planet has tremendous social implications. I'm just giving this one example because I think it's so pedagogic. This is from Olivares and colleagues at the University of Helsinki, whom we've been working with for many years, showing here the very simple exponential pressure graph over the last 100 years of water scarcity. So on the y-axis, you have the number of people suffering from various degrees of water scarcity. The astonishing fact is that 3.5 billion people suffer still today from various degrees of water scarcity, almost half of the world's population. Now that is a drama in itself, but look at the dotted lines. That's the success story of our engineering efforts of trying to solve this problem. This is the exponential growth of storing 5,000 cubic kilometers of fresh water in our rivers, leading to 25% of our rivers not reaching the ocean anymore. It's groundwater irrigations, diversions. It's the modern water systems to try and supply water to a growing population. So we are chasing our own tail. We have more people than ever suffering water scarcity, despite the success story in the Anthropocene, where very high credible evidence indicates that we will have more variability when it comes to water supply, not less, and that we'll have more shocks where water is generally the kind of first victim of climate change. So this is the kind of interactions we now need to incorporate in our governance, economics, and development. This is just a summary of the parameters. You cannot read the indicators here, but this is basically just showing the patterns of if you choose anything from overfishing to deforestation. They have this general pattern of up until 1955, humanity had, in fact, at the global scale, very little impact. We had localized tipping points. We have had collapses of whole societies, from the Mesopotamian irrigation societies to the Maya irrigation society. But up until 1955 or so, we have little aggregate impact. That's where we put in the high gear of what is now defined as the great acceleration of the human enterprise. We're 3 billion people, 10 years after the Second World War, and off we go into the exponential rise of pressures. The warnings came early, as you know. This is Rachel Carson's Silent Spring, warning humanity very early of the risks of this modern trajectory, in her case, attributed primarily through chemical pollution of fresh water. Then came the limits to growth, the Club of Rome report, which was shot down by conventional economists and policymakers as being, a kind of a neo-Malthusian future. But if you look at this curve, you could almost say, well, perhaps humanity could be excused. There was so little empirical evidence at that time to say, where are we heading? Where is the world heading at this point? But today, we're up here. Today, we are standing on a massive amount of empirical evidence at a completely different scale, showing that we are at a very, very top level of exponential pressures, and that if you enter the disciplines of oceanography, climatology, ecology, hydrology, there's so much evidence that we need to bend these curves very rapidly in order to avoid nonlinear changes and impacts on the human economy. Now, where are we then heading today? Well, as you all know, this is just one example for climate. We are, in fact, it seems, accelerating further in the wrong direction. And this is just one of the observations coming from a recent paper by Glenn Peters and colleagues, showing that you may all recall when the AR4 came out in the IPCC, and they had their scenarios from the B scenarios to the A1 scenarios. And IPCC was very harshly, and I think on good grounds, criticized that, why are you presenting these kind of crazy A1 scenarios? They're totally unrealistic. You're assuming 11 billion people on Earth. We won't do anything about reducing fossil fuel emissions. It's taking us to 4.2 to 5 degrees warming. It cannot happen. Why are you scaring humanity with these kind of scenarios? But look at the black dots. In fact, we're following the A1 trajectory. We're following the worst IPCC, the kind of unrealistic scenario, which is taking us to a 50% risk of a 4.2 to 5 degree warming this century. That's why the World Bank put out the risk report on 4 degrees quite recently. And we have more and more research showing that we're coming to a bifurcation point where feedback mechanisms can turn, as in Greenland, from negative to positive, self-reinforcing a trajectory that could take us way beyond the 4 degree warming. Now, you may have seen this paper, which is in the last, this week's issue of Science, which also I think adds a lot of humbleness in terms of how the Earth system responds to our reactions. We've always thought from ice core data that there's a lag time of in the order of 800 years between a rise in temperature and feedback response. So we know very well that in the past, when we were not in the Anthropocene, it was our position to the sun and our position in relation to other planets that triggered temperature rise, but it was only through biosphere feedbacks that it could take us out of a glacial period. Now, this work by Parnanen and others show that probably that lag time is in fact 0 to 200 years, that the synchronicity between carbon dioxide and temperature is much tighter than we previously thought, meaning that the biosphere feedbacks may come much earlier, as we're starting to see, for example, on Greenland. We've been studying very heavily recently the cannery in the Earth system gold mine, the Arctic. The Arctic is the red flag warning humanity very early. There's no place on Earth where we're seeing such accelerated change. In 2007, 30% of the sea ice cover was gone in 2 months. That's one drama, but the other drama was that no science could predict it. It's a total surprise. All models predicted this to be, as a worst-case scenario, something that could happen 2060, 2070. Tim Lenton and colleagues have been showing the kind of tipping points we can see in different subsystems in the Arctic. But then comes this report just recently, the 6 years fantastic work on ice core data in Greenland, where Dorte Jensen and colleagues at the Niels Bohr Institute have been looking at the Eemian, the 200,000 year ago last interglacial, which is the equivalent of the Holocene 200,000 years back, trying to answer the question, did Greenland melt? Now, the interesting thing with the Eemian is that all assessment point that we had a 4,000 year period or so with in the order of 6 to 8 degrees warmer temperature than today. So it's a perfect example of a really worst case scenario, what happened then with Greenland, which holds, after all, 7 meters sea level rise. The drama in this paper is that their conclusion is that Greenland seems to be more resilient than we thought. We've always thought of Arctic being the more vulnerable of the two poles, but it seems that Greenland only lost in the order of 120 meters of ice mass, which could only explain roughly 2 meters of sea level rise. So that's the good news, that Greenland may in fact be able to, as it's doing now, accelerate, but then have some kind of mechanism to stabilize. But the drama is that, well, we know in the Eemian, we know it from very strong empirical evidence, that the sea levels were in the order of 10 meters higher than today. So where are the 8 meters? Where did that come from? And there's only one source, it's Antarctica. So the paradox here is that it may be that Arctic is more resilient, but that Antarctica is more vulnerable than we previously thought. So these are the kind of surprising elements that are, I think, emerging increasingly in the era of the Anthropocene. So to draw a little line here, and this is just as a scientific challenge to us, what if, I mean, we're always talking, and we tend to talk of this period to be, you know, the massive pressures of humanity on the planet, and now is the time to transition. But what if we've only reached the double Apperitif? What if we've not even started the pressures? Because on the social side, it's clear that we haven't put in the social high gear yet. It is a minority that has pushed us to the exponential hockey stick so far. A minority. It is now we're becoming a majority. And what if the Earth system hasn't even started its feedback mechanisms at the big Earth system scale? What if there's actually predominantly a dampening effect so far? We know that 50% of our greenhouse gas emissions are actually absorbed by the biosphere, 25% in oceans, 25% in terrestrial ecosystems. The world's largest, by the way, free ecosystem service to the global economy. So what if these two social ecological accelerators have not even reached the main course? Then we're really in for a very important journey. And this requires new science. And I'll come back to what response science is making there. So that's my little first line just of setting the stage. I know this is not a very attractive way of doing things. I gave this talk once to some business leaders, and Paul Bulk, who is the head of Nestle, said, you know, Johan, you don't have to be nervous about giving this kind of entry point, because my definition of a pessimist is a well-informed optimist. So bear with me. I'll come to some of the possible solutions in the end. But this really argues scientifically that sustainability cannot only be about resource management. It must also be about understanding the dimensions that Simon has been putting out and the entire conference here on complexity, namely resilience thinking, understanding that there are no ecological and social systems. Even Singapore is a social-ecological system, and it really needs to be incorporated in the agenda of global sustainability. And we've tended to pursue science in this way, basically islands of great insights in oceans of ignorance, and we've done great in deepening our understanding in different fields of science. We're starting to understand the crude feeling of the whole, but often it comes out as quite blurred pictures like this. We think we understand the system, but when it clears, we get quite surprised. And I think this is one of the great advantages of this kind of gathering, to start recognizing that what actually comes out on the other end may be surprise, and that we need to prepare ourselves for surprise. And that is, in my mind, all about resilience thinking. And luckily, Simon has covered this much better than I could ever do. But just to summarize, to say that I think where we're moving from is the recognition that we've always thought of systems behaving as the upper left-hand corner, that when you put a pressure and change the condition in an ecosystem, it changes incrementally and linearly, to recognizing thresholds and even hysteresis effects, and the fact that we have multiple stable states separated by thresholds. And when you, as we illustrate often in this cup and bowl diagram, when the depth of your cup is reduced, the system becomes more vulnerable to change. This is the slowing return to an equilibrium, as Simon pointed out, and a trigger can push the system across the threshold. That's why we can have so long periods of slow change, because the system can actually continue to function even though we are eroding resilience, but then a certain trigger can push it very abruptly over to a new state. We're looking at this very much from an ecosystem perspective, and this has also been covered very well, recognizing that both functional and response diversity in ecosystems are absolutely critical to build up the processes of functional ecosystem processes, everything from pollination to the quality of water flows, which in turn provides ecosystems and landscapes and seascapes with their ability to self-organize and deal with disturbance, which in turn provides ecosystem services for human well-being. So kind of quite an empirical evidence base to link from the organism, the microorganism, all the way to the economy through ecosystem services and the strength of landscapes and seascapes to deal with change. And I think this is increasingly well anchored empirically. What we're trying to do is to also link this to what are the sources of resilience in complex social ecological systems, from institutions to sectors like agriculture. And this is a paper coming out from something called RAISE, the Resilience Alliance Young Scholars, led by one of our colleagues at the Resilience Center, Unsi Biggs, and Simon's former PhD student, Maya Schluter, whom we've poached from Princeton quite recently, looking at, and I would really recommend this paper, because it's summarizing 30 years of resilience science to see what are the attributes of systems that seems to be building resilience. And you have issues like polycentricity from Elinor Ostrom's work, understanding systems as complex adaptive systems, but also a red thread that diversity and redundancy critically play an important role to allow systems to be able to deal with disturbance. Now, this is at loggerheads with our optimization and efficiency thinking in our conventional economic model, because actually investing in redundancy can be quite expensive. It doesn't really fit in a normal cost-benefit analysis. It doesn't fit in a monoculture of any sort. So this is quite an interesting change in paradigm also for economics. We define resilience in this way. So I think it's fair to say that Simon's talk focused very much on the first core element of resilience, robustness or persistency, the ability of a system to take a shock while remain in a desired or in a stable state. Doesn't necessarily have to be desired, by the way. The Mugabe regime in Zimbabwe is very robust and not very desirable. But we also include two other features of resilience, namely the ability of an ecosystem or a society to adapt. Basically, you're in a basin of attraction. Singapore, you could argue, is in a desired development basin of attraction. How do you adapt to changing conditions while remaining in that state? And I think an emerging area that we've incorporated within the resilience definition is once you've fallen over a threshold, once you're in a crisis, once you've changed state, What's your ability to move into a completely new development trajectory? What are the social networks, the capitals, the knowledge you need to innovate yourself into a new trajectory? From a fishing system to a business model to an energy utility. So that's how we define resilience. I don't have to go through this because it's been covered very well, but just to share with you that the Resilience Alliance, and we've now taken over at the Resilience Center to be the global repository of something called the Regime Shifts Database, basically cataloging empirical evidence that we have situations of coral-dominated systems in one basin of attraction, long periods of management, which can be more or less sustainable, but gradually it's in fact not meeting sustainability criteria, eroding resilience. A trigger like a El Niño event or a hurricane pushes the system over a threshold, and always looking for the feedback mechanism that locks the system in a new state. In this case, the invasion of soft coral systems. And these systems then flip over to a state that cannot any longer deliver well-being for the 300 million people or so living along coastal regions depending on tropical coral reefs. From clear water to turbid lakes, from savannas to desertified steppes. And there are many examples of this summarized in this regime shifts database, which we think is critical both as a stimulus for science, but also as an empirical base for policymaking, to give a strong justification and feeling of certainty that nonlinear changes actually occur. I'll just go through a couple of examples. You of course recognize this one, which is the classical collapse of cod fisheries outside of Newfoundland, with the tremendous growth in exploitation, the success story of efficiency and growing fish fleets, the total collapse and the surprise of a system that actually changed stability domain and has not recovered since. We've been doing the equivalent type of research in the Baltic Sea, unfortunately coming to the conclusion from very important empirical work in every sub-basin in the Baltic, showing that in 1989, the environmental change in the Baltic shifted from a largely oxic, high oxygen state, rich in cod, low nutrient state, to an anoxic, cod-free, and algal bloom frequent state in a trigger which was probably due to a poor oxygenization during 1 year. So we had a period in the late 1980s that locked oxygen from coming into the Baltic, and we had a state shift. And today, there's a success story here because eutrophication in the Baltic is reducing very fast. The policies are being put in place to really try to save the Baltic, but it's not helping because the system has changed state. And the reason for this is, interestingly, not only because of eutrophication from St. Petersburg and other big cities not having wastewater treatment plants and agriculture, it's also because the cod has been so overfished that the top predator has disappeared. It means that you get an explosion of sprat, which in turn eats up zooplankton, the grazers, which means that phytoplanktons explode. The phytoplanktons get even more happy when they get more phosphorus and nitrogen, and the whole system goes into a totally eutrophied state. And when phytoplankton dies, they consume all oxygen, and the whole system, 60% of the Baltic today, is in fact a dead sea. So biodiversity, climate change, and nutrient fluxes in the Baltic case are interacting to lock the system in an undesired state. I threw these pictures in just before the talk because Simon made a reference to the main lobster fisheries. We've been studying that and others as well, just to show that this is often perceived as a tremendous success story of a community-based collective action on a tremendously effective industry for lobster production. The problem is that it has transformed itself into a massive monoculture. And it's a monoculture that on the short term delivers a lot of good economic outcome, but now we're starting to see examples that because of this tremendous monoculture, it's tremendously sensitive to disease outbreaks, and we're starting to see abrupt shifts and collapse of parts of the system as a result of the movement from a diverse to a monoculturalized system. Moreover, one should recognize that these systems are today totally dependent on fish feed meal coming from other parts of the world. So we're kind of vacuum cleaning different parts of the oceans to be able to concentrate in one place. There are marine regime shifts documented across the world, from the coral reef systems in Australia as I mentioned, to the Baltic Sea. There's a very nice paper that came out quite recently by James Estes and colleagues cataloging the importance of top predators and keystone species in tipping points in ecosystems, for example, as the cod fisheries. We recently published with colleagues around the world a very important work, I think, showing as a rule of thumb, it seems to be that when we empty 30% of fish stocks in oceans, seabird populations tend to collapse. So there seems to be a 30% rule of thumb with regards to resources, which interestingly seems to also apply for terrestrial ecosystems, where Bob Scholes and colleagues in South Africa show that when you lose 30% of forest cover, you seem to also risk abrupt changes. Carlos Nobres and colleagues showing that the Amazon rainforest most likely is more sensitive to a tipping point to savannas than we previously thought. The reason for that, of course, being that climate change interacts with land use change, opening up the system, creating turbulence. The self-regulating feedback of moisture feedback shifts over to be a feedback of drying instead. And we have a frequency of droughts which is unprecedented in the Amazon. And then finally, the work by Tony Barnowski and colleagues showing that we can no longer exclude that we're moving potentially towards a point in mid-century where we could have a global tipping point when it comes to loss of genetic diversity in species richness on Earth. This is, by the way, quite a debated article, as you may be aware, but it's just showing the direction of understanding. You may have seen this work on climate tipping elements by John Schellenhuber and colleagues, cataloging the systems we need to be nervous for when it comes to climate-induced tipping points, everything from the Indian monsoon, which would affect regions like Singapore, all the way to the ENSO dynamics and the ocean conveyor belts. Coming from Scandinavia, this is a particularly interesting graph. This is a NASA picture of the brutally cold winter of 2010 when climate skeptics stepped out and the entire Northern Europe said, hey, where's global warming? You know, we're sitting here freezing like never before, shown in the blue, -4 colder than average temperatures, while the whole planet was plus 1.5 degree warmer than average, just showing a lock-in of cold weather in the northern hemisphere. And you may have seen the very interesting work coming out recently showing that this may be explained by the collapse of the Arctic vortex in 2008, 2009, that held the high-pressure weather up in the Arctic, with that collapse pushing down cold air to Canada, to the Nordic regions and Russia, creating these kind of surprise dynamics when it comes to weather patterns. Again, early days in saying if this is a permanent shift, but interesting. We're now mapping the risk of management-induced tipping points in water systems. So again, interactions between climate and land management are very prominent. And that just shows that this is a very, let's say, a very strong base of empirical science that we can stand on when it comes to nonlinear changes. Now, before entering the two final parts of the talk, one is then to introduce a framework to deal with this, and then to have some pathways for solutions. I just want to point at the fact that Simon talked a lot about moving from ecosystems to biomes and biomes to the biosphere. And I think it is important to recognize that we're starting to understand interconnectedness between systems in a much more profound way. This is so familiar to you, of course, which is the 70% deforestation of the Bali rainforest for palm oil, perhaps the most dramatic and rapid anthropogenic change of any biome, terrestrial biome in direct terms. Now, the drama here is, of course, that we've always been concerned about this when it comes to loss of biodiversity and impacts on local communities. But we're increasingly understanding exactly the point that Simon pointed out, that this changes entirely the fire regimes in these systems. So fire frequency increases, you get impacts on the Asian brown cloud and therefore on the Asian monsoon, which has domino effects on the economy, which trickles back even to the global economy. And interestingly, these kind of dynamics also affect soot fluxes, which causes black carbon also to settle on glacial areas, amplifying melting. We have the work from Huub Savenay and colleagues, which I think, that if this is correct, I think it's a total bombshell when it comes to geopolitics in the world. We've always thought, this is leading hydrologists at the Technical University in Delft. We're working together on a EU project looking at moisture feedback mechanisms in different biomes. And as you're aware, we've always thought that the big rainfall systems essentially originate from evaporation from the oceans. But what this work indicates in red here, showing regions in the world where 80% or more of rainfall originates from moisture feedback from adjacent terrestrial ecosystems. And for example, in the Chinese case here, with more than 80% of rainfall coming from local moisture feedback mechanisms originates from neighboring countries in the West. So Chinese food supply and stability in the economy depends on how Russia, Kazakhstan, Ukraine, all the way to the Baltic states manage their forests. So this is an interdependentness which is tremendous. And similarly for West Africa and Latin America. So these are the kind of interdependencies across big biomes that we need to start considering. So that's my line on nonlinear changes. So 2 sections left here, and we're coming up to the surface here, I promise you. Now, what happens then scientifically if you connect these 2 insights? The insight of the Anthropocene, which is largely about pressures, and the insight about the risk of catastrophic tipping points. Well, that was a question we posed to some 30, 40 leading global environmental change scientists some 3 years back to say, what does this mean for global sustainability science? And to answer that question, we thought the first thing to do, of course, is to say, well, what is the desired state of the Earth system to support human development in the Anthropocene? And interestingly, we believe there's a clear answer to that question. And it comes out of ice core data. And interestingly, this is Greenland, but it's only the last 100,000 years. And on the y-axis, you have a good proxy for how it was to live on Earth, namely temperature variability. It's an important period because we've been modern humans for roughly 200,000 years on Earth. So we've had the same ability during this whole period to, so to say, develop societies as we have today. And it was, as you're aware, a very jumpy ride indeed for humanity during large parts of this period. We were hunters and gatherers. We were very few people. In fact, recent data by Stephen Oppenheimer and others on paleo DNA-based agriculture shows that at this cold point here, where large parts of fresh water was frozen in the poles, we may have been down to 15,000 fertile adults on Earth. 15,000. So we were not only virtually extinct, we are truly family in this room. And the important thing is that we were stuck in the highlands of Ethiopia. We had a very rough time. And that's the point when we left and walked over the Red Sea and started colonize all the way down to Papua New Guinea. So this is probably and deterministically a result of the tremendous uncertainty we had in our environmental conditions. And then we enter the Eden's garden of the Holocene, the extraordinarily stable interglacial with a temperature variability of plus minus 1 degree Celsius. This is the period when all the genetic diversity was there, but it's now that things settle in. This is where the rainy seasons become predictable. This is when when you can rely on 4 months of temperature above 15 degrees Celsius. This is where the wetlands, the marine ecosystems, the forests, etc., settle in as we know them. And we barely enter this period, and we do our most important invention in human history, namely we invent agriculture. And off we go in the civilizational journey we know. We're 3 billion people at the Great Acceleration. We're now 7, committed to 9. So our conclusion is as simple as dramatic. The Holocene is the only state we know that can support the modern world as we know it. It's not as if we couldn't live here. The question is just what world can operate here. And if you take that as your reference point, as a normative statement that the Holocene is the only state that can support the modern world as we know it, then life becomes much more simple when it comes to navigating the Anthropocene, because we know the Holocene very well. We can actually set a reference point on what are the parameters that you need to be stewards of to keep Holocene-like conditions. And that's the question we pose. What does science say in terms of the Earth system processes we need to be stewards of to have Holocene-like conditions? And could we, for each of those, even identify a control variable where we can put a boundary position beyond which you enter a danger zone where you cannot exclude big nonlinear changes that would be undesirable and potentially push ourselves out of the Holocene state? And that became the planetary boundary framework, which led to and was kind of moved through an analysis of looking at, for example, what are the importance of maintaining stable polar regions in order to have them as kind of cooling systems for a Holocene state condition, equilibrium. And that resulted in this work that we published in Nature in 2009, which has resulted in a lot of scientific work and discussions since then. That was the purpose, to trigger science. The important, in my mind, of this work is to show that it's not only climate change we have to worry about when it comes to truly securing human prosperity in Anthropocene, And what we concluded in this work is that we have three, let's say, big systems we need to be preoccupied about: the climate system, the stratospheric ozone system, and the entire stability of the oceans, which have paleo records of big-scale tipping points in the history of the Earth system. But interestingly, this group of scientists also included 4 parameters which do not have evidence of planetary scale tipping points, but which have evidence of being the underlying providers of resilience at the Earth system scale. These are the slow variables working under the hood of the Earth system machinery: biodiversity, land systems, fresh water, and the big fluxes of nutrients in the Earth system. And there's been a big, very distorted debate coming after this paperwork, claiming that we said that there were global tipping points also on land and water and biodiversity. That was never, ever the proposition. The proposition was, what are the sources of resilience? What are the processes that keep dampening and securing that the system remains stable? We also included chemical pollution and atmospheric aerosol loading, which we couldn't quantify. We can come back to that in the discussion. We're now working on a 2.0 paper where we will be quantifying these two, and we have so far not seen any suggestion of changing these 9 parameters, which is quite interesting. But of course, it's a moving target when it comes to defining them. In fact, we suggested in the original paper that they seem to have, our hypothesis is that they operate as a 3 musketeer behavior: one for all for one. If you transgress one of these processes, you change the position of others. If you push the climate system too far, you may have to, in fact, secure more land area in order to keep your system resilient. And vice versa. If you totally deforest the planet, your climate boundary will move very, very rapidly in the wrong direction. We're now working on downscaling these boundaries. So they were set at the global scale. I'm just mentioning that perhaps for interest for you, that we're, for example, on land, looking at what would be the thresholds for different key biomes on the planet. For example, how much forest cover can you lose in the tropical rainforest before you risk nonlinear changes, which would propel back into the Earth system? How far can you lose functional diversity in different keystone species and keystone systems? Because this was a critique coming out of the work. There's been a lot of publications suggesting changes in the boundary positions, and I think one of the most important one was the work of Steve Carpenter and Ella Bennett, suggesting that we've got it wrong on phosphorus. We suggested that the phosphorus boundary be put on how much phosphorus can we load into the oceans before we get anoxic, catastrophic tipping points in the ocean. They said way, way before you knock the oceans over a tipping point, you've actually knocked the whole battery of freshwater systems across tipping points, and therefore you need to couple it with a freshwater boundary, which we have already transgressed. There's a lot of work advancing on ocean acidification, which we put in as a boundary, and I think increasingly showing that this is one of the big, black box, important nervous issues when it comes to climate impacts. And the reason for this is, as you're certainly aware, that when oceans take up carbon dioxide, it leads to acidification, because carbon dioxide plus water becomes acidic acid. It breaks up calcium carbonates in the ocean, and the calcium carbonate levels, here represented in one of them, aragonite, was high enough in the pre-industrial era, in dark green here, to allow for the development of coral reefs in black dots here. So basically, calcium carbonate being the Lego blocks for all marine life, constitutes the backbone for coral reefs and skeletons and shells of phytoplankton and zooplankton and coral reefs, led to the establishment of these ecosystems in the Holocene. And this is the situation today, and this is the concentrations if we do not bend the curves of greenhouse gas emissions. So this is an example of how we're learning more and more of the interconnectedness and the fact that the oceans are playing an enormous beneficial role in dampening greenhouse gas concentrations and climate forcing, but jeopardizing the ocean stability. Steve Runnings and colleagues showing for the first time that the carbon sink in terrestrial ecosystems, in red here, may be going down. This is a drama of tremendous proportion if it would be correct, given again that 25% of emissions are taken up by the atmosphere, but also proof that planetary boundaries interact and that the biosphere needs to be managed in a way that can allow for continued dampening, which is the Earth system response to stay in a Holocene state. Business is starting to show a lot of interest in this. This is World Business Council wanting to have help in science-based influence in how to change business models to incorporate planetary boundary thinking. So we're forcing ourselves to try and define a set of 2020 must-haves when it comes to science-based targets to start moving towards a safe operating space within planetary boundaries. And we're seeing a lot of interest within civil society, particularly to say, okay, there might be a biophysical ceiling for human development within a safe operating space, but what about the social floor? This is the so-called donut model that Oxfam and Kate Raworth and colleagues have been brought forward to say, well, if we're in the Anthropocene, and if we're hitting the ceiling, and if we need to respect the ceiling, we're actually in the realm of absolutes, not in relatives any longer. We simply have to recognize an absolute budget of nitrogen, phosphorus, land, water, and carbon. And then you need to have a fair distribution of that space in a world of 9 billion people. This is, of course, dynamite in the political sphere as well, as you can imagine. But this is where we're moving when it comes to the global sustainability agenda. We're just now submitting a paper to Nature, and this is, I'm coming to my closure here, to try to inform the United Nations work of moving from Millennium Development Goals to Sustainable Development Goals, where we're saying that we've probably moved to a situation where the economy, this is the old steady state economic model that we know so well of, which is, I think, returning into interest today, with the economy to be a subset of society operating within the life support system, and defining a set of sustainable development goals that actually operate in an integrated way with sustainable criteria. So moving away from pillars of sustainability versus economic growth and poverty alleviation to say, for lives and livelihoods, we simply can now define the planetary boundaries or global sustainability criteria within which social targets can be met, and integrating this into a unified framework, which would be the first time it's done. So far, we've largely said, this is the goal, development, and then we try to do as good as we can on the environment, assuming that the planet has this infinite ability to absorb our pressures. The economy is starting to think in these terms. You may have seen Tim Jackson's work on prosperity without growth. There's a growing literature, I think, on thinking in terms of prosperity in the Anthropocene from the perspective of nonlinear dynamics. We're looking into this in terms of planetary stewardship. If we're in the Anthropocene, how can we collaborate, perhaps learning from bacteria and ants and how populations in ecosystems can collectively act. We have so much evidence that transitions to a positive trajectory is possible. I think this is really critical. We can adapt, but we can also transform. And we've been looking a lot at, for example, the big transition in the governance of the Australian Great Barrier Reef, the agricultural revolution in Latin America, moving from plow-based systems to zero-tillage systems to deal with the crisis of degradation into an enormously productive and carbon sequestrating system, recognizing that you need knowledge to see where you're in a crisis and how to move out of a crisis. And finally then, just how to deal with this in a world that will need a lot of time to think and rethink our relationship to planet Earth. It's not as if you can just change values overnight and reconnect societies to the biosphere. And what we're landing in more and more is that we probably need to have a kind of a dual track strategy where there is one fast track opportunity of really moving within, let's call it a bit sloppily, within the obsolete machinery we need to operate in within at the current time step in terms of resource efficiencies, measuring and monitoring and assessing risks, really pushing for a global energy transition, which I think is showing a lot of promise. If you may be aware that a normal Saturday in Germany, the world's fourth largest economy today, 50% of the electricity is supplied from solar panels, largely from individual households, thanks to their feed-in tariff system and reciprocity of electricity markets. You can actually sell electricity from your own household energy production. These are huge success stories occurring in real time right now. And we've recently published this paper showing that you can actually feed the world through sustainable intensified agriculture that meets planetary boundary criteria just because we have such enormous untapped potential in yield gaps. This is the gathering of science to try to address this. You may have heard of Future Earth, which is the effort of the global environmental change research community to move from Earth system science to global sustainability research. It's a tremendous gathering of the International Council for Science, the International Social Council, Science Council, but also the Belmont Forum, which is the big funders of science, to say now we need an integration of social and natural sciences, and we need a more solutions-oriented research endeavor. This starts this year as an effort of mobilizing collaborative research. And to summarize this, then, we probably need to move along these two areas, both adopt and support the work from the United Nations, the climate negotiations, efforts particularly on resource efficiency. It might seem incremental, but clearly a necessity. But then also, as we've published recently in a book called The Human Quest, start really addressing the behavioral change, the value issues, the issues we discussed yesterday on what is it that, how do you couple culture with values, with change? And also moving that all the way to allowing ourselves to say, okay, we live in a world with growth, assuming growth without limits. We had a 40-year period when environmental science talked about limits to growth. Now I think we need to move into a paradigm of recognizing growth within limits, and that's a much more positive trajectory. We have a safe operating space. I couldn't not bring out another Economist first page that, of course, this is not only about environment and natural sciences, it's about recognizing how do successful societies actually operate. I don't want to brag here about what we've succeeded in Scandinavia, but I took this up because yesterday we talked a lot about trust. And the parameter that sticks out here, interestingly, is that the Nordic countries, like no society in the world, has the highest degree of trust between people who don't know each other. So the trust base between knowns is high in many societies, but these are societies that have been able to create a sense of security because trust is high between people who don't know each other. And that lowers transaction costs in innovation and change patterns. So this is the kind of things we need to connect, sustainability with values and what builds trust among nations and within nations. And my final picture is this one, because when I gave larger this talk in the World Economic Forum recently, the chief science advisor to the Dalai Lama sent this picture to me and said, you know, he really wanted to connect religion and value systems with sustainability research. And he said, to inspire this, I send you this photograph, which is from a lake up in the Nepalese mountains, 4,600 meters above sea level. And I first thought it was fake, but it's actually a photography that he's taken. And I just think this encapsulates also, you know, the values that are at stake, and that all cultures, in fact, have strong connectivity between humanity and nature. And I think nobody really wants to deliberately, let's say, destroy our life support base. Of course, there's optimism also in the universality of understanding the beauty of these kind of environments. Thank you very much.
Thank you, Johan, very much. Can we take some questions, please?
Sheila Ranas from Walsh College. In a world of greed and avarice, at least in the United States and the world that I've been trying to function in, I'm also seeing a very alarming rate of anti-science thinking and a value that science is not something useful. Technology is great because it gives us our games and fun things to do, but it's almost disconnected from the science that creates it, because increasingly we're finding populations of both scientific and mathematical illiteracy. Do you have any suggestions for first world countries that are going backwards?
Yeah, that's a very good question. Well, to begin with, just to say that it's not unique to the United States, even though you might be at the front end of that challenge. Now, I've always been a strong supporter of the fact that we need more science-based decision-making in the world. But frustratingly, we're not seeing much of that happening, or at least not enough. What we're experimenting with, which I'm no clue whether it will work, is to be inspired by scientists like Dan Kahan at Yale University, who's done this tremendous work showing that, you know, for conservative Americans, the worst messenger is the scientist, because they've simply a value system that screens off everything that has to do with environment, because environment is per definition big brother trying to control your freedom, and the integrity and freedom is so rooted that in the end you simply almost worsen the situation if you try to just have this linear science communication. And the question we're posing to ourselves is, should we then, and his conclusion is the same, try to co-design and work more closely in alliances with other stakeholders in society, have other carriers of message, business leaders, musicians, cultural representatives, to so to say talk about, not have Al Gore present the inconvenient truth, but rather have people like Bruce Springsteen and young rappers and and a lot. That kind of work, and take that very seriously. I think we're trying to have a science arts focus in a much more strong way to try and communicate in a deeper way. So the Human Quest book, for example, is written with one of the world leading photographers, Matthias Klum at National Geographic, to try and hit both the stomach and the brain at the same time. But it is a highly frustrating situation. But just to give you a little bit of a surprise to me was that we've established a very close collaboration with the World Business Council for Sustainable Development. It is a network of 200 of the largest companies in the world, representing 10% of the world economy. And what they tell us is that we, as in our boards, we listen to science. We take science very seriously. So sometimes I wonder if, on climate at least, if it wasn't so that up until 2009, everyone was listening to science, and then we all went to Copenhagen, and things collapsed. And out of that, the world's political leadership went into some kind of Copenhagen post-trauma, and they're stuck in this trauma still. While business, they never fell over that tipping point, and they had already started to internalize climate thinking, and they're not just moving along. So it seems to me that if this was kind of a Tour de France race, that science has the yellow leadership shirt, and business leaders are trying to hang in there and put themselves just behind science, but politicians are way behind. So that what we see in media may be a lot of the kind of political agenda, while business in many areas are working harder, I think, under the radar screen.
Thank you. Anne?
Hi, Anne Florini from Singapore Management University and Brookings Institution. I have a very specific question for you. I've already been using things like your TED Talk and the Oxfam Donut in some of my teaching here in Singapore. I find the undergraduates very responsive. I don't find the Asian business community quite so responsive. I think the business trends that you're looking at haven't really registered here to the extent that they have in the West. Here's my very specific question. I am lecturing tomorrow in the INSEAD Advanced Management Program for 2 hours. What do I tell them in 2 hours that is going to get their attention and change the way they think?
Well, to begin with, feel free to use any slides you want. Okay, yeah. So that's number one. I would start at I find it increasingly effective to turn the whole story around, to say that there are no environmental issues left anymore in this world. I mean, let's just drop environment. Let's shut down every ministry for the environment. I don't recognize myself as an environmental scientist, because we've come to a point where it's all about human prosperity. That's the agenda. It's about how do we secure growth, development, prosperity, well-being. And because we're in the Anthropocene, and because the pressures are so large, because I think we've done ourselves a great disfavor of talking about global commons and externalities somewhere out there, this big waste bin that we can dump things in infinity. Now that things are so saturated and we're so interdependent, it's all about development. And if you turn it around in that way to say, if it's all about development and you have a number of capitals to deal with, I mean, Adam Smith started off with having land as his prime capital, and then we kind of dropped it along the way and focused everything on technology and finance and human capital. And now we're coming back to the notion of recognizing that the biosphere is our most precious capital. And to put that positive story of putting human prosperity up front, and then say, how can wise management of resources, which is often, in my mind, what business people understand first. I mean, rare earth metals, land, phosphorus, the kind of abiotic resources, but then try to lift in the living biosphere as much as possible into that picture. So that's one tactic, perhaps. But I think the other important tactic is also, which I haven't talked at all about, is just to refer to the great work that is being done increasingly by Pavan Sukhdev and others on the economics of ecosystems and biodiversity, and Nick Stern and others, showing that, well, I mean, Simon and Brian is here and others, you know, really trying to show that it's not anymore about ecological economics and some kind of marginal discipline. It's really about mainstream economy. It's really about, you know, there are 4 European commissioners today who have set up something called the European Resource Efficiency Platform. They want to transform the European economy into a circular economy because they're simply recognizing that the momentum in the world is such that if Europe wants to compete in the world of the Anthropocene, you need to be damn smart on energy efficiency, resource efficiency, and not undermine your ecosystem services. So, you know, somehow change the agenda. We have tended for so long to talk about humans are bad, destroying nature, we need to protect the environment. That is, I think, the absolute dead end of argument. I'm not sure it helps, but I think what you're doing is so important.
Okay, more questions, please.
Thank you. Greg Fisher from the think tank Synthesis. Is this on? No, it is. Right. Okay. I'll talk slightly louder. Okay. Is that okay? So now I've forgotten my question. Actually, it's more of a statement and see what you think, because overlaying a lot of what you've said is the what I would call the profit maximization algorithm. Okay. I think lots of people do have multiple values, but the economy has been run across the world as a single value, which is profit. Okay. Fundamentally, I think my background's in economics. I worked for the Bank of England for 9 years, and I've been at the heart of orthodox economics. We need a fundamental paradigm change in economics. I know Brian has been trying to lead in the sort of complexity economics arena, but I think if we're trying to get, if we're going to get anywhere near the sort of aim that you're kind of saying or implying, we need to get right at the heart of economics and have a paradigm change. The economists don't seem to be able to do it. Okay, which is just astonishing. So anyway, any thoughts on that would be appreciated.
Yeah, and there's so many others in the room that have probably much wiser thoughts than I can have on that important question. But I tend to look at this. At the Resilience Center, we have as one very close part of our center the Bayer Institute on Ecological Economics that Simon has been deeply involved in over the years. And it arises from, if I may allow to say that, let's say the cutting edge of conventional economics, trying to move into and change economic thinking in everything from discount rates to inclusive wealth, and has done so very successfully. But that is really working within the paradigm. It's working with the best economists in the world. The other alternative is to do as the New Economic Foundation, the UK and others, to basically say, the conventional model is obsolete, we need a new model. And it has led, as you know, to tremendous confrontation, at least in kind of an academic confrontation. We tend to adopt the more incremental approach when it comes to economics and try to work with business schools and with the best economists in the world to put economic value on natural capital, to address the fact that discount rates don't work when you have nonlinearities, etc. So to try and build in that kind of thinking. But I'm a very close both colleague and friend of people like Tim Jackson, for example, who I think represent more the alternative model thinking, that we need to totally rethink the paradigm. I think the work that Joe Stiglitz and Amartya Sen and Fitoussi did for the Sarkozy Commission was tremendously important. If we could move beyond GDP just in terms of what we measure. I mean, we only manage what we measure. So in the end, if we just could get a quarterly reporting on our ecological footprint within our national accounts, which in fact I should say countries like Sweden is doing already, it would help. It would take us a long way towards at least recognizing that, we're building GDP, but we're shutting down our ecosystem base. So I think even here you need a kind of a dual approach, deep thinking on new paradigms, but at the same time work with economy, not against economy. And I think we need to do what you'll be doing tomorrow. We need to enter the business schools. We need to enter the best economists, the best economic research training schools in the world, and work together much more. Which, by the way, people like Simon are already doing. So, I mean, there's a lot of that going on.
Anyone in the back? No? Okay, here's a question.
Okay. So, John Richardson from the Lee Kuan Yew School. One of the very hopeful cases has been Japan, and you probably know Junko Edahira's work and some of the work she's done with Alan Atkinson, who I think may have worked with you. I wonder if you could just reflect on the new regime of Prime Minister Abe and his re-emphasis not only on growth but the use of nuclear power and so forth. How does this fit into your scheme of things, and how do you see the scenario in Japan unfolding?
Well, to be honest, I don't know, as a simple answer. I think both Japan and Germany represent big economies that were hit by a social shock, which has triggered a lot of very important and transformative thinking on an energy transition. In Japan, it seems to be bouncing back towards its previous equilibrium, which is quite interesting. That's exactly what has happened largely in the financial crisis as well. You get a shock to the system, but it tends to be so resilient, it bounces back. So I think today, when it comes to Japan, it's quite uncertain where it's heading. I think the more interesting case is, in fact, whether Angela Merkel will succeed in a complete phasing out of nuclear power and therefore also transition into renewable energy mix in Germany. It would be extremely interesting if Japan persisted and became the second economy in the world to show that you can have a well-advanced society depending to a large degree on renewable energy sources. But I think it's still entirely up in the air. But I should say, I mean, that goes for Japan, but certainly also, particularly perhaps to South Korea, as far as I can see from the outside, an interesting trend which seems to be ahead of the curve compared to Europe, to really start integrating growth and sustainability, to start addressing sustainable growth as the integrator, rather than have environment and development in two separate parts. And I think that if some of the Asian successful economies can show that you can actually combine good well-being, strong, transparent, democratic societies with a very good mix of sustainability efforts, I think that would be enormous inspiration and pressure on other countries. I think that the most interesting pressure today is, in fact, the discussion in Europe to say, you know, we're not sure about this whole sustainability issue, but we don't want to risk it, because what if we're left behind? And I think that's a very good pressure.
More questions there?
Thank you, Suman Banerjee, for this enlightening talk. I'm an economist, and I was thinking like not asking question because I always ask question. But it seems to me that economists are given much more credit than they can actually, deserve. It seems to, though I'm an economist by training, we try, there are some micro aspects of economics which people talk about, discount rates, future profits, things like this. But the main thing is that we try to identify natural equilibriums that follows from dominating strategies. Like a lot of these talks from Simon and others, I gathered that many of these are prisoner's dilemma kind of a situation. I mean, if they are not prisoner's dilemma kind of a situation, if it's just a coordination failure, I don't think we need to think too much about it. It will be corrected on the course. But if we are observing a failure for a long time, it must be that these are prisoner's dilemma kind of a situation, that where if you are environmentally conscious, it pays for me not to be and free ride on your responsibility and do even better. And if you are not environmentally conscious, then it's also better for me not to be environmentally conscious. This kind of a prisoner's dilemma kind of a situation might lead to equilibriums that are undesirable, but not much we can do because these are dominated strategy equilibriums. Basically these are ought to happen kind of a situation. So we have to be carefully separate out the ones that are just a coordination problem and ones that are, natural selection models works. Natural selection models are harder to change. I don't know if it is possible even to change, but at least focus on the coordination failure and look at whether we can solve those which are not really, prisoner's dilemma kind of a situation. Okay.
Yeah, I mean, one of the, I hope constructive, but I recognize often in dialogues with economists a bit of a provocative statement is that, often our discussion is to criticize the economic model. I think a potentially more constructive way is to do what I think you're alluding to, namely to say it's not the economic model that is wrong. In fact, it has served us very well. I mean, just look at the past 150 years that, during the period when the planet was not sending any invoices, which is starting to do now, it actually served us very well to consider the planet as this huge free service. And we're 7 billion people, we're wealthier than ever, the GDP has grown 4 times just over the past 30 years. So of course, the question today is, if the model in fact is very effective, perhaps our error is to think that it can solve all our problems, and we apply it everywhere. Instead, we might have to perhaps come to a point where the economy, the conventional economic model, can actually just serve us in very few instances. It can only serve us when a resource is very stable, where there is a possibility of perfect information, and where in fact there is no conflict between different stakeholders, and where there is substitutability. It's an absolute necessity. So every time you have a bistability, and every time you have an unsubstitutable resource, and every time you have competition between different interests that are not well informed of each other, the model doesn't work. And what you need then is political leadership. And you simply need regulatory measures. And every economist recognizes this. Market economy cannot operate without strong regulatory measures. And we're not seeing those regulatory measures play in, which is a bit surprising because in most other areas we're cognizant of the need for regulatory measures, even in the financial system. But look at tax policy or social insurance policy, or the debates in the US now on the entire medical and educational area. But when it comes to the environment, we're very weak in putting regulations to the market to kind of confine and domesticate the market into playing a good role in its confined areas. That might be one way of working as well on the conventional economic area. And I'm sure this stirs a bit of debate, but that could be a lunch or dinner issue.
No, that's okay. Question here?
Hi, I'm Ryan Chisholm from NUS. I'm just wondering, with the growth within limits, just a conceptual clarification, is this, the idea, I guess, that you can keep growing as long as you obey the limits. Is this just a new twist on the old idea of internalizing externalities and, incorporating them across the environment in our analyses? Is it the same thing, or?
No, I would argue it's distinctly different, because what limits to growth clearly alluded to was that there was a biophysical limit to how far we could generate, let's say, well-being in whatever indicator you use, which was clearly proven wrong because it underestimated our ability to innovate. For example, the world energy system, or the world's electronics system, or medical systems, or particularly the food system. If you instead turn it around and say that the Earth system has these biophysical boundaries, and that they are absolute. We don't know them exactly, because we cannot interview Earth. We cannot sit down and just talk to the planet and have it answer the questions, where are your boundaries? There will always be uncertainties, but if you have that safe operating space, then I think there's a lot of debate, but there's a lot to support the idea that you can actually have a lot of continued growth, even in GDP terms, in the world within a safe operating space. You can move into, you could in fact have a circular economy operating and generating more and more wealth It would never be 100% circular, but I mean, you could largely confine yourself in a way that stays within, let's say, a biosphere which is not put under too large risks. So it changes, in that way, it's a profound difference. And I think that was the, in a way, mistake of the limits to growth analysis, that because it talked about limits to growth, it had to make assumptions on technology, on policy, on even human needs. What the planetary boundary work and growth within a limit does, it for a moment, which is a bit awkward for complexity scientists like ourselves, to take out humanity for a while and put it aside and just ask the question, the Earth as a system, where are the biophysical boundaries? And once those are defined, you put back humanity, and then you allow humanity to innovate or move as she wishes within that playing field. And that becomes a much less threatening approach to development than making assumptions that kind of tie in, so you cannot develop more than this or this. Of course, if we are not successful in finding innovative solutions, you'll in the end hit the ceiling, and then you come to a limit. Then you come to a limit to growth situation. So for climate, for example, we're there. But I think one of the big paradoxes which we seldom discuss is that what if we're successful in a transition to a total solar energy future? Will that be sustainable? Well, it could be if we have the regulatory measures to assure that the rebound effects does not just mean that we propel ourselves into even more accelerated consumption. So you could actually see a situation where even a totally successful solution of the climate boundary could actually propel negative impacts on other boundaries. So it's not as if sustainability in itself is the solution. It's really just recognizing that we need to stay within a certain type of playing field. For my students, I try to sometimes just make the analogy. It's like we're running the economy as if you would try to play football without having the line on the sides of your field. But in football, you know very well that as soon as the ball is outside the court, the game stops, and then you play again. But inside the field, you can have both Leonard Messi innovating, and you can have a person like myself who can barely hit the ball. But everyone can fit in that field. So that's the change, I think, in terms of analogy.
We have time for a few more questions.
Just to follow up on Ryan's question, your last point there, I got when you talked about what a full solar economy might do, it might change where the limits are, where we can go. And so, which I thought was Ryan's point, which is that there's a feedback. And so maybe we can't take humans out and define what those boundaries are and then put them back in, because the boundaries co-evolve with technology and population growth.
No, that's a very important point. I mean, when it comes to the climate system, I think there's a good, let's say, scientific basis to say that it's hardwired in terms of when, for example, the ice sheets melt, irrespective of the driver. The driver could be natural, the driver could be human, but essentially it's a physical system. But you're right in the way that in the Anthropocene we could geoengineer ourselves to a point where we could shift the position of boundaries, for example. And that kind of geoengineering does not necessarily have to be science fiction. It could be just the way we intensify use of biomass. You're right. I mean, the way we manage oceans could change the position. So you're right. In the Anthropocene, this is an element that we haven't addressed in full. What happens when you couple and make analysis on different kind of investments and big schemes of changing management?
One more. Who wants the last word? How about you, Steve?
Jamie McCaughey at the Earth Observatory of Singapore here at NTU. When faced with uncertain information about the future, people tend to wait and see. How can we better frame scientific uncertainty, and what kind of decision support might weaken the status quo bias and encourage collective action?
You know, that's such an important question. We had your colleague here, I think he's somewhere here, talking about this yesterday, that, I mean, uncertainty needs to be, I think, translated, which we often do also as scientists, into risk and talk more about risk and risk in terms of consequences as far as we can do analytically, which is often difficult. But I think just to talk about uncertainty and kind of standard deviations is not very helpful. We need to somehow take it to risk and consequences. And one discussion we had yesterday is the fact that perhaps the best industry in the world to do this is the reinsurance industry that basically holds the risk of all natural disasters in the world, companies like Swiss Re and Munich Re. And we're increasingly trying to learn from them of how do they do in their assessments of uncertainty, how do they deal with uncertainty? Because they're putting insurance premiums on every risk you can dream of. I mean, everything from a drought, a flood, an earthquake, a nuclear power breakdown. And so I think we as scientists also have a lot to learn from how industry within particularly insurance business are dealing with these kind of uncertainties. So that's one area. But the second one is, of course, like a Don Quixote, just continue to fight the windmills on the need to internalize the precautionary principle. I mean, the Economist's statement here of the need for a certain degree of nervousness is a reasonable response is written in, as you know, into the 1992 UN declaration from the first Rio summit that the precautionary principle must apply when we have uncertainty. It's not being applied anywhere, but it's being applied in so many other areas. I think if you look at any business leader, any politician, they're so clever in taking decisions under uncertainty. But when it comes to uncomfortable decisions, we tend to use uncertainty as an excuse for not acting. So it's not as if we don't act under uncertainty, it's just that we're unwilling to do so in some circumstances. So I think we need to work on both these areas.
Thank you. And let's please thank Johan Rockström again.